Good afternoon, everyone. My name's Steve, and we're about to start our afternoon training on script functions. Um, so let's get started in the script functions. There we go. So script programming, it's useful for programming complicated processes using higher level languages similar to C. Not exactly like it, but it is similar. The FC6A can be programmed using script or ladder, or a combination of both. Combinations of ladder and script can save programming time. The script files can be exported and imported into your program to save programming time, and that means that repetitive programming used across platforms or different machines can be standardized and reused. So script is a function for programming complicated processes with conditional branching, logic operations, arithmetic, and functions as text. However, there are some limitations. Calculations that have both bit and word data are not allowed, and data types inside of a single script function have to match. So the first thing we need to do after you configured your program, your PLC and your system, you go to your project window, and you can get to the script manager two different ways. You can use the project window, and down here you'll see where it says script manager. Or when you drop a script into your ladder program, which you'll need to do if you're going to use the script, when you double click on the function block, the script manager is right here in the reference box in the middle. When you open the script manager, you can add, edit, and delete scripts. You just add it by hitting the add button, edit it by hitting the edit button. You got to highlight the script and then hit edit button, or highlight the script and delete it. When you open the script manager and you're inside the script, you give it an ID. This can be from 1 to 255. You give it a script name, whatever you want, and then the data type that you're going to use inside the script. And this is important, and we'll go over this as we're going through the script of why your data type is important. There are some functions that are not allowed if you're using float, and there are some functions that you can only use by having your data type as a float. So what is a data type? A data type are words, integer, double words, long words, and floats. A word is a 16-bit data, and the biggest you can have from 0 to 65,535 in there. An integer is a signed 16-bit word, and you can have from negative 32,768 to positive 32,767. Double words are unsigned 32-bit words, so they can go from 0 to 4,294,967,295. And then long words are signed 32-bit words. They could go from 2.1 billion to positive 2.1 billion. And then floats are real numbers with a decimal point, and they could go from negative 0.3 or negative 3.40 10 to the 38th power to positive 3.4 10 to the 38th power. And when you're doing your scripts, the data type and the range of the data that you'll be using, that'll determine what type of data type you use in your script. So what is a ladder versus script? This program right here that you see in ladder is exactly the same thing as this down here on the bottom written in script. You're taking a data word, you're converting it from in D0 to D10, You're taking D10, dividing it by 10, putting it in D12, taking a D12, multiplying by 1.8, putting it in D16, taking D16, adding 32 to it, and putting it in D14. I can do all that in just these 2 lines right here in script. So you can see how it can save you time and space in your program. You can also use bit. I could turn an output on. This ladder right here is written in script right here. If input 1 or Q1 are on, or Q0 is on, and I don't have input 1, but this down here is input 3, then turn Q0 on. So basically, this is just latching itself in. You can also use the bits from a word, like D300.01 and not D301.01 or D302.01. And then if any of that condition is met, then set D303.1, else 303.01 is reset. So basically, these are both the same thing, but they're written. That's written for inputs, and this is just using conditional formatting to do the exact same thing. The only difference is what you feel more comfortable using. It's like ladder. You can write it any way you want to, as long as it works the way you want it to work. So let's get started with programming. So what I'm going to do is open up my ladder, or my PLC WinLadder software, and after I configure my PLC, and what we're going to do is I'm going to use the K-type thermocouple here that's already in Celsius, because it's coming into my PLC and already being converted. I want to convert that to Fahrenheit because I need to use Fahrenheit also. Okay. So what we're going to do is we'll write a script to convert that. We'll write some ladder to convert that to a float, and then we're going to use the float inside our script to convert it to a Fahrenheit temperature, and then I'll use that to control a heater and a fan on the PLC. If at any, I'm sorry, I forgot, and I got a little ahead of myself, but at any time you have any questions, write them in the question box, and at the end of the presentation, I'll answer all your questions. Okay, so let's get started. So I've got my PLC set up. I've got the module configured. I got all the IP addresses set. I go to my home tab in the main program, and I have an instruction set toolbar up here, and also view the project window. So I want to add a input or a normally open contact to my program. So I can go up here to basic and grab my normally open program and drop it in the blue box, which acts as my cursor in the ladder logic. Okay, and then I have to tell that what it is. So I'm going to say I'm going to make that input 2. Input 2 is a switch on my PLC. It's a selector switch on my PLC set up here on my desk. So when that's on, I want to convert a data type. Now there's 2 ways I could do this. I could go to advanced instructions, and I could go down to where it says data conversion, and I could pick convert data type. Or if I know the mnemonic, I could just type it in, and it'll CVDT, and it comes up convert data type, and I could just grab it from right there and hit OK. Now, in my module configuration, I have the thermocouple coming into the PLC as an integer. All right, so I want to convert an integer to a float. And I have the thermocouple set up as D00, which is the data for analog input 0, okay? And I want to move that. I mean, I want to, when I convert it, I want it to put it into a D10, okay? And hit OK. Now, if I download this to my program right now, okay, okay, and then I go to monitor mode, and I turn switch 2 on, you can see the analog input data comes in as 270, which is a number that I don't know what that means. So I'm converting it to a data type, and you'll see it gives me 275.0, okay, or 276, whatever that is. It turns it into a float, okay. So what I'm going to do now is I'm going to put another normally open switch. I'm going to still call that input 2. Input 2 is going to start my script, and I will put my script in the program here. And S1 is a pointer that tells me what script to run. Like I said, I can have up to 255 scripts in my program. S1 is just telling me which one I'm going to run, and I'm going to make it number 1. Okay. Now the destination device is actually, or D1 is just an area where it uses 2 consecutive bit registers or data registers, and it's basically where if there's any error in your script or there's some kind of fault with the script, the status will be in this data register we're going to give it. Okay. So I want this data register to be way out of the way. I'm just going to put a D266998, which is one of the last data registers that are available to you in the FC6A Plus. You have that many data registers to use. So I hit OK. But I still haven't put my script in there. So if I open back up, I hit the reference number. This is from earlier class, I'm sorry, but I want to edit. Let me just start with an add. I'm going to delete this. And sorry, I should have deleted this already before the class started. So that's what it looks like when it first pops up, and I'm going to hit add, okay? So you can see where it says number 1 up here where the script ID is. That's the pointer right there, S1. I'm going to run script 1. Now I can name it whatever I want. I'm going to say temp conversion. And I know that's spelled wrong. And I'm going to use float in here. So I'm ready to start. Now, this script program is like C, in that the syntax follows C and C+ very closely. However, you don't have to include a processor directive, like the hashtag include IOStream. And there's no need to define the body of the program with like initialize main or main in with the parentheses after it. I could just start typing. But one of the things it does do that, and let me open up my viewer here so you can see this a little bit better. If I hit 2 backslashes, you'll notice it turns the script green. And anything behind the 2 backslashes are notes, or basically run comments, and are not executable. You know, you don't want to try only to annotate complicated parts of your program. And not everything. It uses up memory, and things that are easily recognizable. You don't need to annotate. For instance, what I'm gonna do now is I'm gonna put my little brackets in here, and I'm gonna put a data file in here, D12. So D0012. That's the symbol for data. That means data register 12. Okay. I want that to equal D0010, which is the float that we converted in our ladder, right? I'm going to divide that by 10. I'm going to end this line of script, or I'm going to end this executable wrong, and then I'm going to put the parentheses back down here. So basically what I'm going to do is I'm going to take whatever's in 10, I'm going to divide it by 10. Whatever's in D10, I'm going to divide it by 10 and put it in D12. What that'll do is give me a real number that is in Celsius. For instance, before we came in here, the number in D10 was 279. So what'll be in D12 is 27.9, which is actually 27.9 degrees Celsius. So then I'm going to convert. I want to convert D14 I want to convert that into Fahrenheit. I want to convert D12 and I'm going to put it. I want Fahrenheit to be in D14. So I put my parentheses in, and I'm going to take D0012. I'm going to multiply that with the multiplication little star by 1.8. And this is just like algebra in school, guys. You know, anything inside the parentheses is done together. And then I'm going to add 32 to that. And I'm going to end my line of script. And what's going to happen now is whatever's in D12 is going to be multiplied by 1.8, and I'm going to add 32 degrees for it, 32 to it, and that in D14 will give me whatever the Celsius reading is in Fahrenheit. Now, there's some other things I could do inside here too. I don't have to just use float. What I can do is I can use bits in here. I'm sorry, I can't talk and type at the same time. So what we can do is we can turn a heater or fan on depending, and I can't spell either, obviously, depending on the temperature and a set point, an arbitrary set point that I give it, okay? So I'm going to use the conditional formatting. And in conditional formatting, if I do not have these two double spaces in front of, like if I write if like this or else, they're in green because, you know, they're behind the double brackets, right? But if I don't put the double brackets in there and I put if in there, it knows that if is a conditional statement, so it turns it blue, actually. So if, and this is my condition, if D0014 is greater than, right? Yes, greater than, let's say 80 degrees. And close my brackets there, close my parentheses. And then I have to put I have to put what I want it to do, right? My action. So I'm going to open up bracket. So if it's that, I'm going to take Q0004, which is my fan, is equal to 1, which means because it's a bit, means it's on. And I'm going to close that bracket, and then I'm going to do another. I'm going to open up I'm going to do else. I'm going to open up a bracket. Q0004 is equal to 0. I'm going to close that statement off and close my bracket. Now I'm going to do so this section, that section controls the heater for the fan. So if say D014 is less than 80. I'm sorry, the first top was for the fan. This is for the heater. Then I'm going to open up a bracket, and I'm going to tell it what I want it to do. So if it's below 80, I want it to turn on the heater. I'm sorry, yeah. Q0055 is equal to 1. And then I'm going to close my bracket. I'm going to do an else statement. Else, if it's not that, open up another bracket. I want Q005 to equal 0. And then I'm going to end that statement. And I'm going to close my bracket. So I'm going to change the Celsius to Fahrenheit, and then I'm going to use that Fahrenheit number to, if it's above 80, I want to turn on the fan, and if it's below 80, I want to turn on the heater. Right? So to make sure that I'm correct, I can always do an error check here, and there's no errors in the script, which means that it should run. So I'm gonna save. First of all, let me take this out of here. I'm going to go down here and hit OK, which saves the script. And I'm going to hit select that one and hit OK. So now I'm going to download this to my program or my PLC. Okay. Now I'm going to go online and monitor it. So to see what's happening in the script, I'm going to come up here to my custom monitor. I'm going to do a new custom monitor. And I want to look at D0, which is an integer, right? And then I want to look at D10, because that's the number I first converted to a float. And then I'm going to look at D12. It is also in a float, because this should be my number. This should be my number in Celsius in true temperature, 26.5. And then I'm going to look at D14, and that's also in a float, because that's my temperature in Fahrenheit, 79.5. So now I'm going to look at Q4. This is a bit. This is going to be my I can't remember if Q4 is the fan or the heater. But anyway, it doesn't matter. And then here's Q5. It's also a bit. So right now, Q5, which is the heater, it's on. And when it gets to 80, you can see it turns off, and then the fan comes on. If it gets to 80. By closing off the exhaust. Maybe you should put this a little bit lower. So you see, when it gets to 80 degrees, it changes, and the fan comes on, and the heater goes off, and then it starts to cool down, and it'll try to maintain that set point. Okay. So I'm going to take it out of monitor mode. I'm going to start another run. Sorry, I didn't want to do that. Please. Flat line. There we go. So let's do some conditional formatting. And I'm going to show you how to import text files too. So that's what we'll do. We'll import a file that I've already created. So I'm going to put a normally open switch in here, right? This one I'm going to call M8121. Okay, it's a 1 second clock. And I am going to add to that 1 second clock a single output up. All right, and then I'm going to put my script in here. Function block. And I'm going to call this one script 2, okay? And I'm going to give this one D266996. It's just a data register that it has to be in there. I hit the reference symbol, and now, so there's my first script. I'm going to add one to it, and I'm going to call this one 2, and I'm going to call this one conditional. Or you know, I'm just going to count a counter. I'm going to create a counter inside the script. So I've already done it once, so I'm going to show you how to import a file. So if I hit import right here, it'll go to all my scripts that I have written already, right? So I'm just going to select that one and hit open, and you'll notice it puts it in. It already puts the script in here, already written for me. And basically, all it's doing is it's taking M8121 and it's moving it into M50. If M50 is equal to 1, if D51 is less than 32, add 1 to 51. D51. If it's equal to 32, else D51 is equal to 0. So basically, all this is going to do is count up to 32, and when it gets to 32, it's going to reset itself back to 0. I can do an error check on this, and there's no errors in the script. So I say, okay. I'm going to select this one, hit OK, and then go to online and download this to my program. Okay. Okay. So now I'm going to go to monitor mode. And you'll notice that clock is clicking off every second. It's a M8121 is a pre-programmed bit in your PLC that acts as a 1 second clock. It's on for 500 milliseconds, off for 500 milliseconds. I want to see what's happening inside that script, so I'm going to come up here to custom and do a new custom monitor, and I'm going to look at M50, not M51, which is a bit, and I'm going to look at D51, which is a word, and you'll notice it's counting up to 30. It'll count up to 32 and then reset itself back to 0. And then it just goes back to 0. So it's just basically acting as a timer. Now, what happens if I take that STU out of there? Let's try it. If I take this out of here and I just add the script and I download this to my program, it runs completely differently. Because now what happens is whenever M8121 is on, and it's on for half a millisecond, it will count every time it scans in that half a millisecond. So if I go to monitor now, and I go to custom batch, and I make that M50 a bin for a bit, and D51 for the word that I'm using inside of there, you'll notice it counts up really fast. So basically what it's doing is for half a millisecond, it's counting every scan time. And you can see how fast it's scanning through that small program that we've just written. That's why I put the one stop there in front of it. We'll take it out of monitor mode and put our one shot back in front of there, our single outputs. So it'll run like a counter again. Now, so now I've shown you, you can do math and conditional formatting. You can also do bit in your program. So let's do one more. We'll call this one M80. It'll run all the time. M8125. It's just going to always be on. And then we'll do another script in here. And we'll call this one number 3. And we'll put this one in D66994. And open this up, hit reference, and then we're going to add a new one. So this is going to be a bit usage. So I can program my PLC also to run. If you can write it in ladder most of the time, you can do the same thing in script. The only problem is just knowing how to do it. So let's turn my magnifier back on again so you can see this better. Down to 200. Okay. So what I want to do is I'm gonna open up a bracket, and I'm gonna say I want to control Q. Let's see. We'll do Q6. Q6. Q006 is a pilot light on my demo for the heater. So Q6 is equal to, or is equal if, or on if input 002 is on, or, and the symbol for or is this straight line between it, or Q0006 is on, and I have input 0003. And then I'm going to close my brackets. So what that's saying is if input 2 is on or Q6 and input 3 is on, then Q6 will turn on. Then input 2 could drop out, but Q6 will still be on because it's either input 2 or input or Q6 are on. And I don't turn off I3. So this is a latching circuit. This is a latching circuit. Okay. Um, I want to also show you that you can also do this in conditional. You can use data word individual bits. Also. So I'm going to do this as, instead of writing it out like this up here, I'm going to do this as conditional. So if let's see, we're not using D300, D300.01. Okay. And the inverse, I can use the, so this is like a normally closed switch. The inverse of D, let's see, 0000331.01. And I'm going to do another and statement here. No, I'm not. I'm going to do an or. I'm going to close that off. And then do an or. Let's see. We'll do D 0332.01. And then, so if D that actually would have a 0 in front of it. 0300332. So if this is on and that is not on, or if this is on, that's my condition, if, right? Then I'm going to put my bracket in here. I'm going to set D 303.01. And I'm going to close my bracket. And then because I have it else, I'm going to do I'm going to do else. I'm going to open up a bracket. I'm going to reset our RST, I think it is. D 0303.01. Close my bracket. Oh, I got to close this up here too. I also have to end the statement, which I forgot to do, and I also have to end the statement. Enter, and then I'm going to close my bracket. There we go. So I'm going to do an error check, and it gave me an error. So I think let's take this out of here. Uh-oh. So E30, 331, 33201. Reset else. Oh, 330, 1331, 0332. Did I forget to do this right here? Error check. Okay. All right, what did I do wrong? If I got the bracket open, bracket closed, that's set. Else, bracket open, reset, bracket closed. Error check. Let's see if this is. Let me get rid of that real quick. Error check. No errors in the script. So it wasn't the script. Let's just do this one right now, and then we'll come back to that the condition in just a second. And hit what else you could do is just do. You could also just if you ever get stuck like that and you don't know what you did wrong, if you just do the else if or if else and insert the format, and then you can let's see D 0300 300.01. And D 0301.01 or D 0302.01. Close that, and then else. I need to do it. I want to set D 0303.01 else. I want to reset on RST D 0303.01. Close that and then hit the. There we go. Error check. No, okay. So I must have done something wrong. I just don't know what I did, but it's working now. So I hit OK, and then hit select and hit OK. So I'm going to download this online. Download. Hit OK. Okay. And then I'm going to go to monitor, and I'm going to create a new custom monitor. This is going to have a Q4 in it, right? I want to have input 2. I want to have input 3. I'm going to change these all to bits. Bit, another bit here. Bit, bit. I had a D 300.01. D301.01, I think I did. D302.01, and then D303.01. Okay, so let me hit save here. This is gonna be my bit. Hit OK. That's another thing I meant to show you. But if you hit save and then give it a name, you can close this out, and then when you open up your new custom monitor, you don't have to retype in everything again. You can just hit the file that you want to look at, and it'll go right to it. So I'm going to turn off this right here. Okay. So my fan's not running anymore. Now I'm going to go to custom open my bits, right? So you can see I3 is on, which is I'm going to turn it off, right? I'm going to turn it back on. I2 is off. I'm going to turn it on. So now, because I2 is on, let me show you here. Q7, right? Which was a bit. Or was it Q6 that I used? Q6. Yeah. All right. So Q6 is on, right? So so now it's off again and I'm using my switches to turn it on and off on the demo. Turn that on, and there we go. So yeah, that needs to be Q6. There we go. So you can see Q6 is on. I mean, you can't see that it's on, but it's on now. And then I can turn it off, right? And then I can reset input 3, but Q6 stays off until I turn Q2 back on. And then Q2, once I turn Q1 on, or input 2 off, Q6 stays on because it's latching itself in. And it will stay in until I turn I input 3 off. Okay, and then the same thing with these bits. Like, so input, this is off, right? And then if I turn this bit on, change it to a 1, it turns input 3 on, right? Or it sets that. And then I got to turn this off and this off before it'll reset itself. So you can see that you can use the bits and the inputs and outputs in your program in script without having to write them in ladder, and they still work exactly the same way. Okay, so what I'm going to do now is I'm going to go to questions and spend the next couple minutes going over questions for you. So let's see what we got. Does the destination register become a float since you use 10.0 in the equation? If you would use 10, would that make it an integer? Well, I want it to be a float because I don't want to mix and match my data registers. But yes, it would be an integer unless I change it to a float. But since I'm adding a 10.0 to it, I'm changing it to a float. And the reason I did that is because I need it to be a float for the next rung of code. In the script, you're using memory addresses. Can you use? Yes, you can also use tag names. So let me show you that one real quick. If take it out of monitor mode, and if I go to view, and I go to the tag database. All right, so instead of, let's go to these data registers. So D10, if I call that float underscore temp underscore C, and then D12 I call float underscore temp underscore real, and then in D14 I put because I put a space in there. I just put this temp underscore real underscore C. And then D14 is temp underscore real underscore in Fahrenheit. And I use these as my tags. When I go back into my script and I go to reference and I go to edit, you'll see that it changes the data. I could put my tag database, and I don't have to use the data file. I can actually use the tag database. I can actually program using the tag database instead of using the data files. Yes, the attendees will receive a full version of Automation Organizer. It's on our website. I'm not exactly sure how you get that, but when I answer these questions and post them online, I'll have somebody put the link in there for you to go to get it from. Oh, well, the data type's a float, but I'm not using I can only use floats in this if I'm going to do a line of code. I'll show you how. I didn't explain that very well. Let me explain that better. Temperature conversion again. Hit select. Okay. Reference. There we go. Edit. This right here equals an executable line of code. This right here, right? Everything inside of there has to be a float for this to work. Same thing here. These are all floats. This is not a float, but I'm not doing any math or any kind of calculations with it. I'm just saying if the temperature is below 80, then set 1, else turn it to 0. The same thing here. If it's below 80, turn this on, and if it's not, turn it off. So yes, there are floats and there are bits inside of this program, but I'm not using them together in executable lines of code. I hope that answers your question. Let's see here. The next question. Where do you divide the centigrade by 10? Why do I? Oh, the reason I divide it by 10 is because when I change it from an integer to a float, monitor online, there we go. When I change this to a float, I get 27.2, right? Or 272.2, which is not the real temperature. I want that to be I want it to be the real temperature. So the real temperature is actually 24.2. So I have to divide that number by 10 to get it to be 24.2 from an integer to a float. Because basically when I'm converting this, I'm just taking that number and converting it to a float. I'm just adding a 0.0 to it. So I have to divide it by 10 to get to the real number. Yes. So the script library files are just text files. When I exported them, let me show you. Let me see if I can't pull it. File here. When I exported them, I just put them into a file I already had made, and they're just script files, or just on my notepad. And I can edit them here. I can change the numbers here, and then I can import the file into my script, and it'll change the number there too. Whatever I write in here will be written directly into my script. Now, one caveat to that is, all right, so say I change this, right, because I want it to be 60 now, and I want this to be M60 also, and I want this to be M551, right, instead of this. When I import this into my text file, or when I import this to my hit file, save as let's put a change. Hit save. Okay, so there's the change script right there. We just changed it inside of our text file, outside of the PLC program, outside of WinLadder, right? I'm going to go into my script, right? I'm going to take it out of monitor mode. I'm going to go into my script here. Now, I'm going to edit this, right? There's the code, right? There's the old code. If I don't erase this, and I just put import, and I hit import to change, open, it imports it, but it puts it at the end of the code. So there's the M60, M551, 551. If I wanted to replace that code, I have to delete the old code before I import it. Or I can delete it now, but it doesn't overwrite the code that's in your program. It just adds it onto the bottom of the code. Okay, so if you want to change it and you don't want to keep this code, you have to delete that first, or after you import it, you have to delete the section of code you want to replace it with. Okay. Unpin this again. Yeah, they're created in Notepad. No, there's not an equivalent of the SOUT or SOUT down and used in script. You could probably build your own, and you can build your own, but there's not one. There's not a script function for that yet. I mean, that you could just drop into your program. So to use the and add and not, yes. Well, actually, no. And means this and that. The other one was, and I'll show you here in this is a better way of looking at it. I hope you can see my screen. Let me move this out of the way. You can see here, calculates logic and of expression 1 and 2, right? Or now up here, or down here, I'm sorry, where is the bit operators? Or up a little bit higher, I think. This is directly from the manual. I want to go to your bit operators. Arithmetic. There you go. Bit operators. Here we go. If I put that little squiggly line, what it does is it inverses the logic of bits in A. If it had that right there, it just inversed the logic. So it means if it was 0, it would then be a 1. If it was 1, it would then be a 0. And you can use that with words, integers, double words, long words. You cannot use it with a float. And this is where I'm talking about where you can't. If you're using a float, there are certain things you cannot use with a float, right? You can't use these bit operators with a float. You can use them inside of a data type float, but you can't use them in the same script as a float, or the same executable line. Hope that answers the question. How do I type if the keyboard does not have? What is the title? Not what the title symbol is. Oh, yeah, it does. It does have. If you look, that straight up in line, wherever your forward slash is, if you hit the shift key and your forward slash, that should be your straight up line. If that's what you're asking. I hope that's what you're asking. Let's see. Yes, and is equivalent to and. Is usable as not? No, there is a. Actually, that straight up in line is. Well, that squiggly line is the inverse. The not is actually. The not is actually. Well, you know what? It's easier to show you in the program. Here we go. Let's move this over here. Reference. So if I go to here, go to edit. If you look down here where it says bit operations, right? There's and, or, XOR. There's the inverse bit. There's or. You're talking about these like conditional logic operators. There's not right there. So it's an exclamation point in front of the parentheses that have the operation inside of it. It's that little parentheses right there. Or statement is D0 and then 2 double lines or D1. And the and statement for Boolean logic is and AA. So yes, I hope that answers those questions. Let me see here. Unpin this again and get over here to okay. Yeah, I have the letter O instead of 0. Okay, you're right. People are just pointing out the mistakes I was making. Thank you, by the way. Set and reset are instructions, by the way. These are just to tell me how to program it. Yep. All right. So where are the IDEC manuals located at? So if I go to our website, the IDEC website, IDEC. If I go to IDEC's website and I go to support, there's 2 places you can get the manuals at. So let's go to project. We'll go to products. If you type in the product, you have like a FC6A C16. Hit search. So if I go to view product, there's a literature tab down here, and on the literature tab, you can see. Let me get this out of your way. I can scroll down to where I have the data sheet, the brochure. Here's the user manual. I could download that for free. The ladder manual, I could download that for free. The communication manual, I could download that for free. All right. This is out of the ladder programming manual. It's chapter 26 where script is kept. So it's in this manual right here, and you just hit download, and it downloads the manual for you online, and then you can save a copy of it to your computer if you want to. That's one place you can find them at. And then also, if you go to our automation products, you go to PLCs, Microsmart PLC here, you can find all of them right here too in the literature. So you can either find them under the product page on our website, or you can find them under the family page on our website. And that's for every one of our products. Now, some products, of course, don't have user manuals and programming manuals. For instance, like industrial components, circuit breaker switches, and stuff like that. There's data sheets on there, and the catalog pages are in there, but there's no user manual for those. Okay, let's see what else we got here. If you use a tag, yeah, we did the tag names already. Title. Yeah, okay, so that should be underneath right next to the one on top. Well, I don't know, it might not be on your keyboard. And are they case sensitive? No, it doesn't seem to be case sensitive. You can write, if I write small case D000000, it still knows that it's a data register. Like I said, it's like C in that in like a lot of the syntax is the same. However, you don't have to include like a hashtag include IOStream as your processor directive, because the only directive that the only processor this is going to talk to is the FC6A, and the memory is already fixed on there, so you don't have to tell it where to go because it already knows that. You don't have to define the body of the program with like initial main or main in parentheses. You can just start writing your code. So I have guys that really know how to write in C++ and C++ that have absolutely no problem with writing programs in our script. And I know enough about C++ to be very, very dangerous, and I can still write programs in script because IDEC has done a lot of the work for me. All I have to do is, if I want to do something, go down here and grab it, and I can insert that format into my program, and I don't need to know how to write it. It writes it for me, basically. And it'll also tell me when I make errors and show me where those errors are. The one drawback is it doesn't always tell you exactly what the error is, but the function is there. It's a very powerful tool for you to use, and I hope you guys learned something. And that's all I have for you today. So I'm going to stop recording now. Thank you.